M5C2 test circular motion, question number 9. A Winter Olympian doing the luge, as illustrated below, so that's that event, is travelling around a banked turn on an ice track. The radius of curvature of the turn is 32 metres. The angle of the banked section of the track is 55 degrees. Calculate the velocity at which the Olympian and the luge will experience no frictional force to their left or to their right in order to maintain a circular path around that section of the track. This is quite a common banked corner question. If I start graffitiing the picture itself, you've got two forces acting on the luge here, and that's the weight acting straight down and the reaction force from the surface of the track acting perpendicular to the surface of the track at that time. They're the only two forces. If you were to do a vector sum of those two forces, it would produce a triangle with mg acting straight down, the reaction force acting like so, and the angle between those two would be 55. So the resultant of these two forces will be the length and direction of this portion here, and this resultant force will be providing the centripetal force, so that's mv squared over r. And now we're in a situation where we can link the weight of the lugist to the centripetal force via this right angle force triangle, and we'll be linking the adjacent and the opposite sides using a tan function. So up here I'll write tan theta equals the opposite over the adjacent, so that's going to be mv squared over r is the opposite, and mg is the adjacent. The m's cancel, and I can rearrange to make v the subject. V is going to be the square root of, so let's see, the m's have cancelled, it's going to be rg tan theta, square root of. The curvature of the path is 32 meters, Earth's gravity is 9.81, and the angle of the banking is 55 degrees. Make sure your calculator is set to degrees.